Okay, thanks for joining us for the Western Wheels Conference. A couple quick things before we begin. If you need a certificate, you'll find the link for that here. You'll need to submit a separate request for each session that you attend, and you should receive your certificate in email within 24 hours of submitting the request. If there are any handouts available, you'll find those there. And if you're interested in learning more about any of the products featured in our sessions, that'll take you to the product page for each one. And if you click request pricing, that'll add it to your wish list. Here we are at the wish list. You can either complete the form and submit it right away, or you can keep browsing around and adding items to it to get one big quote. And you can always get back to your wish list right up here in the top right-hand corner. That's it. I hope you enjoy the session, and we'll see you on the other side.
This year, Al has only given me an hour to teach. That's my brother from another mother there, my elder brother, by the way. But he's only given me an hour, and I'm going to try to stay to it. You've been in some of my sessions and our sessions on scopes, and this one is a brief one, but it's more how to teach scopes to your students. And I'm passionate about that. I know Al is also. The scope has been around for years, but its efficacy and its importance to proper diagnosis of today's vehicles has never been more important than it is today. This is the handout that John is releasing to you now. If you don't get a copy or you want another download link, get a hold of him or me. It's called Teaching DSOs to My Students. It's just completed, so it's 2021. I hope you find it helpful. There's a lot of information in there on some of the things that I'm going to go quickly with today, but don't worry because everything is there and you'll have more detail in the handout. Should you be teaching scopes to your students? And if so, how did you go about accomplishing this? How would you? Again, you remember my usual stand up in front of you. I'm from the old school, and I have text on my PowerPoint slides, and darn it, I'm going to read some of it to you. So deal with that. With all apologies to Jeff Curtis, but that's how it's going to be today. We all know that hands-on learning is still the best method. Here's a picture of a classroom in a shop, actually, with 25 or more U-scopes set up on a table, and the instructor is in front with the PowerPoint, and then the cars that the signals are coming from is over there on the left. Now, this is a phenomenal way of teaching oscilloscopes because each student has their own scope, needing to make the necessary adjustments and settings to see the correct pattern. Why should you be teaching scopes to your students if you're not? This is a test that we all know has been in service information for years. It's called a TPS, or throttle position sensor, or APP sweep. And I suspect you've all done it. And what you did was hook up an ohm meter or a voltmeter if you're live to the throttle position sensor signal, and this is basically what you did. If I can get this to work here. So basically, we saw at idle, the voltage is about 0.48, about a half a volt, and then we slowly move the throttle down, seeing the voltage go up, and then this meter, maybe you saw the voltage scale change, which confused a little bit, but I'm sure all of us, if I was to ask, have done this test, and in my opinion, it's one of the most worthless, wasteful tests you could ever do because it's designed to see if there is a bad spot in the sensor. And of course, this meter is not really capable with update speeds of seeing any glitch unless it's really bad broke. And I yet know you've probably taught this and demonstrated this to your students. Now we're going to use an oscilloscope, in this case the U-scope, to do the same test, and let's see what we see. Now we're moving the throttle fast to wide open throttle and back again. And now we're going to go slowly, and it's going to run off the screen and pick back up. So that is doing a sweep test using the oscilloscope. And of course, if we had a bad spot in the resistor, the throttle position or APP, it would show up on the scope as that momentary glitch in the signal. No meter can see that, and yet a scope can. And this, of course, could cause the tip-in hesitation, the miss. This is the glitch usually occurs where the majority of the time the driver spends his foot. So this is the first evidence that I want to give you of why you should be teaching oscilloscopes to your students. There's 20 plus reasons in the handout why you should be involved yourself with students and oscilloscopes. This is one of the biggest things that has hit the industry today, is using the DSO to conduct relative and actual engine compression testing. It only takes a fraction of the time to do it, and you get much more accurate information than you ever did from that pressure gauge screwed into the spark plug hole. You can determine cam and crank timing issues. If the phasers are out of time, if your chain is loose, you can determine which valve is leaking. Is the intake restricted? Is the exhaust restricted? All of this can be done with compression testing. The only tool that we feel can accurately diagnose CAN bus systems. You really need a scope today if you don't want to spend a lot of time in guesswork trying to diagnose a CAN bus issue. The scope is your friend here. Current ramping is not new anymore. To some it might be, but this is the most accurate way of testing motors, injectors, coils for very accurate diagnosis. We look at the current ramp, and we'll talk more about that in a little bit. And of course, it's the only tool that can catch and identify intermittent glitches. These are 4 of 20 plus reasons that if you're not teaching scopes to your students, you should. Do you have a shop, or do you have a scope in your shop? And if so, how many? Yes, they are expensive. I'll talk about Pico and other brands here in a little bit, but most of you don't have the budget to purchase 20 Pico scopes. So the types of scopes that we have, the digital storage oscilloscope, this is the old Sun machines that we had were called analog scopes. They did not record anything. They were live, and when you lost the signal, the screen went to flatline. The digital storage oscilloscope can store waveforms for playback. And there's a bench type unit, which we don't see much in automotive. And then of course, there's the portable handheld. Maybe some of you had the old Fluke 97 and 98, which was a great tool and still is. And of course, the U-scope is a portable handheld tool. Here's just a few of the many scope brands that are out there. Many of you may have the Snap-on or Snap-on scan tool, the Solus, Veris, or whatever with the scope attachment. The Autel, of course, has scope features. And then there are handheld dedicated scopes like the ATS, the Bernie Thompson's e-scope. Pico, of course, is a leader in the industry. But these are the different brands. They can be PC or tablet based, which is what the e-scope and the Picos are. They can be integrated with a scan tool, as we know. And then channels. Every scope has at least one channel. And how many channels do you need? So you have a 1 channel, which is the U-scope and a few others. You can have a 2-channel scope, Pico or OTC or Tektronix, Handtech, Fluke. They make a 3-channel Pico, but it's a non-automotive scope, although you can use it on a car without the software. And of course, 4-channel has become very popular. That's personally what I have as a 4-channel. And now they have 8 channels. Do you really need 8 channels? Well, it depends, but in some cases, yes, you do. But most of the time, a 2 or 4 channel scope will satisfy most of your needs, but a single channel scope is an awesome teaching tool and a diagnostic tool also. This is the new Pico. I wanted to spend a couple minutes talking about the new Pico 4425A. It's available in a 2-channel and a 4-channel. Looking at the back of it is a little different than those of you that have Pico scopes. You see the BNC connectors, and all of the accessories that you currently use with your Pico scope will work with the new 4425A. However, some of the new leads that you see have these LEDs on the back of the scope, and you have these 6 pins attached to the harness to whatever is connected, be it an amp clamp or a COP probe, pressure transducer, or whatever. This is a neat feature because now it eliminates all of the batteries that used to be in all of the amp clamps and all of the external features. So the scope provides the power to these accessories. You don't no longer have to worry about batteries or calibration or zeroing out or anything like that. It's done automatically, and the LED lights up telling you what color channel on the readout that connector is connected to. It's kind of a neat feature. So this is what some of the new harnesses look like for the new Pico scope. That's a COP one at the top there with its connector. There's an amp clamp. Again, no calibration, no choosing the right scale on the screen. It's done automatically for you with a simple plug and play. Low amp, high amp. This is the Pico Master Kit with the new scope. Of course, you can sink a lot of money into these things if you wish, but you can also not, get everything that the Master Kit covers. Again, your existing connectors with BNC will work on the new scope, but without all of the extra features that those new designs come with. So what should you do? You have an older scope now. Let's say it costs X. How much does the new one cost? It runs about $300 to $500 more than the non-new scope. Now, Pico is going to slowly drop off supporting the BNC only type of scope, and they're heading towards this. You can still buy the 4425 or the 4225 2-channel. They're going to become more and more hard to find. And of course, we know with the pandemic, getting product availability, no matter what it is difficult. But right now, you still can get both. But eventually, the older scope will be phased out. And if you're using Pico 6 right now for your software, they're also going to start phasing that out. Pico 7 is available, but it's still in beta. And pretty soon here that I'm told that they're going to go to full Pico 7 software for running your scope. But Pico 6 is still functioning, and I use it every day. Oscilloscope accessories, your scope will be connected with either banana plugs or BNC connectors. They make adapters to go either way if you need them. Of course, you need a set of probes. You may need needle probes. You may need wire piercing probes. The jury is out whether that you subscribe to piercing or not. Alligator clips, the ignition harness with your secondary pickup, and COP paddles. And now, you see all kinds of tricks that people are learning. They're using things like putting a relay coil on top of a COP coil to get a signal. Some people even use a penny attached to the scope. So there's new technologies coming out every day because scopes are becoming, as I said, much more popular. The amp clamp is a vital tool within oscilloscope, and if you have an existing amp clamp that you use with your digital multimeter, it will work the same on your scope. You don't need to buy new amp clamps if you have ones that function well for you. They can be adapted to your scope. The pressure transducer kit is what is used to measure pressure high pressure, low pressure, hydraulic pressure, in-cylinder, cranking pressure, vacuum. All of these things can be made to work with the scope by using a pressure transducer kit. And this is what the buzz of the industry is right now. This is called in-cylinder pressure testing, where we actually see the pressure changing inside the cylinder based on the 4 strokes. And we know what a good one looks like, and we can tell by the changes in the pattern whether the exhaust valve is leaking, the intake valve is leaking, or whether there's restrictions on either end of the intake and the exhaust. It's a phenomenal testing tool. There's all kinds of classes out there now on in-cylinder pressure transducing. CTI has Brandon Steckler is kind of the guru in the country right now, but this is a phenomenal way of diagnosing engine problems. GM just made the Pico a required tool for dealerships, but only because they want to use it for vibration testing. So here's a kit that makes your scope into noise, vibration, and harmonics. By sending out to different locations, you attach it to different places in the car where you suspect noise is coming from, and the scope will help you pinpoint the problem. Of course, we have thermometers that we can make the scope to read temperature, and this is especially true when Rick talks about measuring super heat and subcooling on air conditioning systems. You need a lot more than just that little infrared heat gun that we always used to use. The scopes have attenuators. An attenuator allows the scope to read voltages higher than the highest setting that the scope came with. So it's like a voltage range extender, and they're 10 to 1, 20 to 1. And you use them primarily with high voltages, such as with ignition systems and fuel injection systems, where we don't want to peak the scope with too much voltage. You can hurt a brand new Pico scope by putting too much voltage into it. You can do that with any scopes. You want to be aware of what voltages you're testing. Affordability of scopes, if you're going to be adopting a teaching program, this is something I just wanted to point out. You can go online and get what looks like a U-scope. They're called clones. They're only about 99 bucks. I've seen them actually a little cheaper, but they don't have the software in it that the AES Wave U-scope has. It's really a piece of junk, bluntly said. Whereas the U-scope is totally different. It has its firmware and hardware and software all custom designed by AES Wave for the automotive applications with presets and all of the tests that are programmed into the scope. I just want to make you aware. Yes, you can buy a U-scope clone online. I want you to look at your handout, and you don't need to do this right now, but there's a relatively new document out, which is 60 plus pages on the user guide or user manual for the U-scope. This link will be in your handout. It's a free download. I suggest that if you have a U-scope or consider getting some, I would strongly recommend you download this manual. This is what you get when you go into the link. You fill out your simple information of your name and company, and then you will get a download link. When you send this in, you'll get a download link. It's a PDF, by the way. Someone asked, why is ConsuLab teaching classes on oscilloscopes? What in the world are you doing this for? First of all, we believe that the DSO is now an essential diagnostic tool. You're really doing your students a disservice, in my opinion, and I'm not alone in this, by not covering oscilloscopes, be it at a high school or post-secondary. This should be in your curriculum now. We are passionate, as you know, about helping you in your daily job, helping you become more efficient, making it easier to assist your students in developing their careers. That is our passion. All of us on the team feel the same way about that. We know there are many school programs that are not up to speed on scopes for whatever reason, mostly budget-based but we know that there are some schools that are asking for help. We are so vitally interested in the success of your students and in their careers. We are seeing many more success stories than ever before of students who are becoming trained technicians at many different levels and seeing a rewarding career in their future. We are very much want to be part of that. We feel we can help you with this subject matter, with our resources and the training that we give. And we have affordable products to assist you with this topic. This is not a sales presentation, but I just want to explain to you why we are doing scope training. And of course, we make some pretty good signal generators. Many of you own some of these products, and I'll talk a little bit more. Yes.
We're seeing an email on your screen.
Seeing what?
An email on your screen.
Oh, wow.
Or a document, Word document, sorry.
A Word document.
Yeah.
I don't even have Word open. Let me close all this. Sorry about that. Do you see the PowerPoint now?
You're going to have to reshare.
Oh, you're right. I don't know what happened, gentlemen. I'm sorry. Are we there now?
Yes.
How many slides did you miss?
Go back a couple.
Three.
Did we see this?
No.
Okay, this is the topics that I just talked about, why we are teaching a scope class to instructors. And I talked about each one of those topics. The previous one before that, I'll have to back out of each one of these here. I'm sorry, I don't know what happened. I've never happened before. So did you get the download for the Uscope user guide?
Yes, that we saw that one.
Okay, great. So this is why we're teaching the class today, and I won't take the time to read these again, but basically we want to help you, if you're not up to speed on teaching oscilloscopes, to do that with you. And if anything we can do to assist you in this, please contact us, because we are passionate about doing this. So there's the trainers, that some of the products that we have that generate awesome signals for using oscilloscopes. This is our latest, of course, you know, many of you own our engine benches, and this is basically a running vehicle without the sheet metal. So anything that you could get off a car, you can get off of the engine bench also. And of course, you don't have to have the car in the room to do that with. And of course, our newest engine bench, it comes equipped now with what we call an SLP, or student learning platform, and it's tablet based, which students are very adept and comfortable using tablets now. So no more fault box, no more opening, turning switches, pushing buttons. Everything is tablet based now with touch screens. So they can go in and set up diagnostic scenarios, which sets faults into the engine. The engine responds with the corresponding negative operating conditions, trouble codes, and so on. And we also put, and this is a new feature, we put a DLC breakout box right in the trainer. So you don't need to have a separate one. And of course, this is very handy for teaching diagnosis at the DLC with CAN bus and other features. Plus, you can plug your scan tool into this also. This is the EM330, which is, we call it Al's baby. This is a functioning basic engine without the smoke and without the noise. However, what's neat about this product is we can vary critical sensors. We can adjust them, and the engine that responds accordingly with all of the PID readouts on the scan tool. The diagnostic trouble codes will set. This is a very powerful teaching tool, and Al will do more with this in his session. This is the speed and position trainer, and I've hooked my Pico up to it to show you the 4 different patterns that are available here. This is the common variable reluctance sensor, the Hall effect switch, and 2 magnetoresistive sensors, which is the new ones, the low and high resolution that most of the vehicles today have. Where do you get other signals if you don't have anything like this? Well, the vehicle, of course, is probably the best source. However, we have accessibility problems for 30 students to watch what you're doing when you're hooking up a signal or getting in there to access this. Plus, the vehicle has to be in the shop with all of the environmental concerns that are there. Again, accessibility and student viewing is a problem. ATS, Bernie Thompson's company, makes what they call the E-Trainer Junior, which is a circuit board. Maybe some of you have sat in classes using this board. It's a pretty good tool that can be accessed for signals. You can buy signal generators online. They're limited in their use, but you can generate signals from retail purchased equipment. Of course, many of you recognize this as the Snap-on, the old style signal board that you used to be able to buy. I think you can still buy it. This is one that's been adapted to be a banana plug by simply soldering connectors to the board, so you don't have to use alligator clips. Of course, the one they have now is the one on BMW for scope signals. Maybe some of you have this if you're in a Snap-on program. They also make one for a scan tool based on a town and country. So, okay, you've figured out a way to get signals. How do you start teaching scopes to your students? And these are just my personal suggestions. This is nothing that you'll find in a curriculum per se. This is just how I do it. If you're not up to speed on how a scope works or how to set it up, get this handout. You can get it from me. You can get it through John, whatever you want. This is the introduction to the digital storage oscilloscope. I presented this in Florida several years ago where you actually had a U-scope in front of you. But if you want that handout, it's available. This is what a scope is, how to set it up, and how to read it. If you can get this handout from, this is the one that Al did on using a scope in the classroom. This is a pretty powerful teaching tool for using the scope with your students. There's also a brand new class that we are offering called U-scope buttonology and features. It's how to use all of the full features of the U-scope, every button, every menu, every adjustment, how to obtain the preset waveforms that are stored in there that many people don't even know about, how to customize the screen for your uses and so on. How to store waveforms, retrieve them, put them into a PowerPoint, put them into your assignment sheets or your smartboard. This is a brand new class that we offer. It's about a 3-hour class. It takes a long time to go through all of this, but if any of you are interested in that and have U-scopes, get a hold of your rep or me, and we can talk about presenting this class to you. Okay, how do you start teaching scopes to your students? First thing I do is compare something to what they already know to a scope. And we all know that a scope is nothing more than a voltmeter. So it's a visual voltmeter displayed over time. And I start out with a simple drawing on the board. We know from all of the movies that we see when the guy is hooked up to the heart monitor and he dies, he flatlines. There's no voltage generated. So there's anything flat on the screen is no voltage and it's just time. So we can be off, no voltage. We can be on up to a certain voltage, whatever that might be. We can stay on, we can go off, we can stay off, go on, stay on, go off, and so on. So that is either an on or a off signal, which we call a digital signal. It's either on or off, and that is displayed over a certain adjustable period of time that we can change the scope to display microseconds or seconds or even hours. Those are digital signals. Analog signals can do anything they want. They can drift all over the screen. They can be up, down, long, short, whatever. So our scope can measure both digital or analog signals. What skills are required to become good at using an oscilloscope? First, you got to be able to hook the scope up and get a pattern. That's the easiest thing to learn. You know that it's a voltmeter, so you want to plug something into the circuit that you're testing to get a signal and a ground. That's the easiest. Secondly, once you get that pattern, you have to determine, is it what it should be or not? And the only way you can know that is to know what a normal circuit pattern should look like. And that's called known good. And I'll give you all kinds of resources on how to find out what known good patterns are. That's the medium difficulty. You got a pattern, is it good or not? That's the second skill. And of course, the third one is, if the pattern is not normal, what part of the car, what part of the circuit, what component is causing that pattern to be wrong? That's where the difficulty factor is. And the only way you can become proficient at that third level is to hook your scope up to something regularly, which means practice, 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 practice. And one of the best ways to do that is to hook a scope up to a circuit or a car that there's nothing wrong with it. So you begin to see what a normal pattern looks like. And then when you hook it up to one that isn't normal, it's easier to recognize. How do you read a pattern? You read it the way that I use an analogy of John Hancock. If we had him in the room and we know his signature, we've seen it a lot, he would say, okay, is that my signature? I say, John, did somebody forge your signature? How would you tell if someone forged your signatures? Well, I would look at the length of how I wrote. I would look at my little things that I do with squirrely on the pen, that little tab right there, this little part over here. I could tell by looking at my signature if it was a forgery. And that is exactly the way that you read an oscilloscope pattern. Every little nuance, every little trace, every little bump, every little vertical or horizontal part of that pattern needs to be looked at to determine if it is what it should be, and if not, what is the problem. There's three essential things you need to know to teach a scope. You need to know about voltage per division, time per division, and trigger. Those are the three crux issues of teaching an oscilloscope. You need to discuss the screen. Anything across the screen is time, anything up on the screen is voltage. And the per division means each one of those squares is a division. And we can adjust the scope to display so much time per division or so much voltage per division. And yet some scopes allow you to adjust it so that you see, okay, there's going to be 12 volts displayed from far left to far right. That's screen voltage as opposed to per division voltage. This is a cheat sheet that I put together. It's in the handout, Intro to the DSO. It's suggested settings for voltage and time to test the common sensors and circuits of the car. You can find this information in other places, but I've given it to you in that handout. Keep it simple. Keep it simple to your students. I don't know how many times I've sat in scope classes where the guy says, okay, up is voltage, across is time. Now let's talk about a case scenario that I use the scope to fix. And it just blows everybody away. Compare a scope to a voltmeter. Discuss how much faster the update rate is on a scope. Most scopes sample at 1 million samples per second. I think the update rate on a Fluke 88 is like 7 or 8 samples per second. A scope is 1 million. So you will see signals that you don't see on a meter. Discuss that voltage goes up on a screen. Discuss that time goes across on the screen. And trigger is an adjustment that you can put on the scope that will start the display of the pattern or synchronize it to your setting. I would suggest staying away from teaching specific component waveforms at the beginning. Especially stay away from case scenarios until they have a better understanding of what a scope is. Keep it simple, up and across. The following are simply my suggestions to get started. Where do I get signals from? Well, we're telling students that this is a voltmeter, so this is what I would do. I would have them hook the scope up to a C battery, 1.5 volts. And then they're going to, okay, if this is a voltmeter, your scope should now be telling you what the voltage of that battery is. And it's something they understand. It's easy for them to comprehend, and whatever the need to adjust on their scope to show 1.5 volts can be easily done. Then I would use a 9-volt battery and then a 12-volt battery. So you're simply getting students involved with basic stuff to show them that a scope is a voltmeter. And because this is DC voltage, these are straight line voltages, so you won't get any fancy patterns on the screen where you got to start thinking about time per division. This is strictly DC straight line voltage. It's the easiest thing to start out teaching scopes to students. Now, once you get past the DC voltage, I would use a signal generator. Now, the U-scope comes with a built-in signal generator that you can adjust the frequency and duty cycle on, which is a very powerful teaching tool. So I'll show you basically how to use the U-scope. It has an adjustable, again, signal source, or you could use a trainer if you have a trainer that will generate a duty cycle and a frequency, not a problem. Now we're going to show you the different ways of connecting the U-scope signal generator to the signal harness. You see there's a 3.5 millimeter mini photo plug right here that plugs into the side of the scope, and it has a white and a black connector that connects to the needle probes if you have them for your scope, or you can connect it to a paper clip and use this green probe right on the paper clip. Or you can use alligator clips and connect them to the signal generator output. Or you can cut the white and black connectors off and use 4 millimeter receptacles, however you want to do it. Now, the reason that they put this little tiny signal generator harness on the U-scope is many instructors were trying to use the signal generator built into the U-scope and display it out onto other devices like a computer or even the signal distribution harness. And that signal generator is designed only to power up one U-scope and one display. And if you start getting creative and start plugging it into other things, you will burn up the internal signal generator and damage the scope. So that's the reason they made it a little bit difficult for you to do anything with it other than to loop it right back into the U-scope that you're using. Here's a couple of displays of the signal generator on the U-scope. You see that I have used it to adjust different frequencies. Well, you need to make sure students understand that frequencies change, sometimes with speed, sometimes with air on a MAF sensor, sometimes with other components. But the frequency can be measured. We can have students use math to measure it, or some scopes give you a readout of frequency. And this frequency is adjustable, by the way, on the U-scope. Frequency, in this case, changes with speed. We want to make sure that they understand duty cycle. Duty cycle is important today with pulse width modulated circuits, fuel injectors, ignition, and so on. Here you see two different displays of duty cycle. One says 14% duty cycle, one says 87% duty cycle. We want to make sure they understand what duty cycle is. Now, on the screen on the left here, we see that it's 14%. Well, what does that mean? We see that the right one is 87%. Well, wait a minute now. Looks like this one is on more than it's off, but it's only 14% duty cycle. What's up with that? Now you must understand that the student needs to be taught about ground switched and power switched circuits and the effect on duty cycle displays. So on the left side, you see that this is a ground switch circuit. So that's why it's only on a little bit of the time. So we want to make sure that students understand duty cycle, ground switch, and power switch control circuits. Cursors. Cursors are critical point of knowledge that students must understand: how to use cursors, how to adjust cursors, how to turn them on and off. Each scope has a little bit different procedure for how to using cursors, but on the U-scope, it's really simple. The cursors are basically two horizontal lines that you can adjust your choice, up or down. And when you turn your voltage cursors on and the two horizontal lines appear, you get a delta V, in this case 6.00 volts. That means that between those two white arrows that you adjusted, there's 6 volts of displayed voltage. That's voltage cursors. Time cursors are vertical lines. And again, they're totally adjustable, left and right, each one. And the time is between the left arrow and the right arrow is a delta time of 33.2 milliseconds in this case. Now, when you're working with coils and fuel injectors and pulse width modulated circuits, cursors and time and voltage measurements are extremely critical. So your students must understand cursors very well. You can give them different exercises in using cursors to measure. Trigger is an important concept to understand. We have auto trigger, we have norm trigger, we have single trigger, and we have hold. Most scopes have these features. Trigger slope, that is either the positive voltage rising going up in the signal or falling down. So we have positive slope, negative slope. Some scopes use plus and minus, some scopes use arrows, some scopes use this graphic symbol. Again, that is how the pattern begins to be displayed on the trigger, and you've set it for positive or negative slope. There are places in component testing where you want to use both. Here is a signal that is displayed in auto trigger, but it's drifting back and forth. Why? Because you chose auto, which is most of the time you'll be in the auto setting. However, the trigger level that you've established is not within that signal. So it tends to drift back and forth, telling you, excuse me, your trigger level is misadjusted. Here is an actual video I took of my U-scope. This signal is again unsynced because the trigger level is set too high. There's that yellow line that represents the trigger level. It's set at 5.68 volts, which is higher than the signal being displayed. So let's see what happens when I adjust it properly. So here we have an unsynced pattern. Watch the line going down. And as soon as it hits that pattern, boom, it's synced. It's still live, it's still changing, but it's synced. Now I'm going to raise it back up again, and now I have an unsynced pattern. So if your scope or your student's scope starts looking like that, all you've done is your trigger is misadjusted. Now, if you're on the norm trigger mode, that's saying that you have told that scope to not display a pattern until it crosses either going up or down. In this case, you see the up arrow, so it's going up until it crosses 12.6 volts, which is this line right here. We're on 5 volts per division. So you've set that at 12.6 volts. So the signal that you've connected the scope to is either above that or below that and has not crossed that threshold. So you think there's something wrong with my scope. No, in normal trigger mode, you must have a signal cross the threshold that you've set the scope to. Amp clamps. I want to make sure you understand how to use the amp clamp with your oscilloscope. You can do current ramping, relative compression testing, starter draw, alternator, coils, relays, motors, voltage drops. It's very critical tool with your scope. Here, I'm current ramping. You connect the current probe around a wire, single wire, and of course this one would have to have a battery test made and a 0 of the amp clamp out. And I'm going to measure current by using an amp clamp. And again, the same amp clamp you are using with your meters can be used with a scope. Here is a typical fuel pump current ramp. I've connected the amp clamp around the fuel pump positive wire. And if you'll see that pattern, it's a little crazy, but you see that this yellow, the white line right here, there's a one time cursor, there's the other time cursor, and I chose that because you're looking for repeatable patterns. So here you see a repeatable pattern, there's another one, there's another one. So I set my 2 time cursors to those repeatable patterns. Once you do that, that represents 1 revolution of the fuel pump. And it took 9.12 milliseconds to make 1 revolution. Well, with that information, we can start calculating some things that we need to know about testing fuel pumps. So if it took 9.12 milliseconds for 1 revolution, it took 109 RPMs in 1 second by just doing that simple math. Then we take that times 60. That pump is running at 6,578.94 RPMs. And that's right in the middle of a good specification, by the way. And they're starting to list pump RPMs now in service information. There are 8 commutator segments on this pump because there are 8 distinct patterns. 1, 2, 3, 4, 5, 6, 7, 8. Some are 10. Most pumps today are 8 segments, and you can tell by the current flowing through each of those segments that they're not even. And that's beginning to look like this segment right in here may be arcing at a low current. We got some problems going on with that brush or that commutator segment, and that's why this pump is a little bit shaky and it is on the cusp of failing. Another method of determining RPM is, there's 60,000 milliseconds in a minute. Therefore, 60,000 divided by 9.12 gives you exactly the same calculation of speed. Al likes the first method. I like the second method, whatever. So staying with generic signals first to understand the voltage per division, time per division, trigger frequency, duty cycle, cursors, and current measurement. Once you do that, you want to check their mastery of that, we move immediately to a fuel injector. And this is the easiest thing to show the advantages of a scope. So here's a fuel injector. We connect it to a B+ power through a fuse. We have a PCM. We have the ground side of that injector going to a switch in the PCM. And that's what turns the injector on and off when we ground switch it. We can hook up our scope signal point here to voltage anywhere in that line, be it a connector or pierce the wire, which I don't recommend. So here it again is the same circuit, but now we're going to measure voltage here. And we're going to measure current here. Again, current is the same anywhere in a circuit, so we could hook our amp probe anywhere on that in this circuit, but the voltage we want to be on the ground side. So now we have a 2-channel picoscope, and we see the red is voltage and the blue is current. Now you can't do that with a U-scope because it is a single channel, so you need a 2-channel to display both current. You could do current and voltage separate with a U-scope, but you're going to see the advantages of having a 2-channel scope here. This is a powerful teaching tool for students because this explains how the circuit works, not just looking at a pattern. So here we are with B+ voltage running at 14 volts or so with the engine running. What happened right there? Well, if we were in a room, I'd ask a question. Some of you would say, well, voltage dropped to 0. Well, why did it do that? Because the PCM commanded the injector to come on. It closed the ground circuit. And if we're on the ground side of the injector, that voltage is going to drop pretty close to 0. And then current starts to ramp up at C. Does that mean the injector opened right at this point? Many of you would say yes. The answer is no. It did not open at that point. During this time, the injector voltage is close to 0, so we know the injector is commanded to stay on during this time. And right here, the ECM said, injector, we don't want you to be on anymore, so we're going to release that switch. We're going to open that ground switch. And of course, we know that we have current flowing in a coil, and you break that circuit, what do you get? You get an inductive kick. And that's what this represents, is the inductive kick of that fuel injector. And then it slowly dissipates down back to B plus again. So between these two lines right here, we see the injector command on time. Now you need to learn that that is not the injector open time. That is the injector on time, or pulse width. Now we're going to use the scope, and it's the only tool that you can do this, to actually see how long the injector was open. Right there, you see that little characteristic bump. Well, as the voltage started dissipating and going down to 0, the pintle inside that injector, which was no longer being affected by the built-up magnetic field, closes. So that hump right there is called the pintle closing hump, and then the voltage stays at B plus for the rest of the time. This hump in the current, and you can see that when we closed the switch to ground the injector, the current started to increase, but it still wasn't strong enough to overcome the spring and the pressure inside the injector until right there at I. This hump is called the pintle opening hump. So the injector command is from there to there. The injector opening time is from there to there. So there's the closing hump, there's the opening hump, there's the switch closing, there's the switch opening. This is the open hump in the current waveform, the closing hump in the voltage waveform. We want to make sure that the time between the closing and opening humps and the time of the pulse width is within 1/10 of a millisecond. If it isn't, especially if red is longer, it's proof positive that the injectors are dirty, clogged, partially restricted, or mechanically broke. And the scope is a great tool for determining the health of a fuel injector. This is my proof of why you should be teaching scopes to your student. Don't look at pulse width and think the injector is staying on longer. The computer may be commanding it because the injector is not squirting enough fuel because it's stuck or restricted. So the pulse width is going to increase, but the opening time isn't. You can use captured waveforms, and these are homemade assignments that I've made with. You can ask the student to look up the connector view, knowing where to put the scope, how to hook the signal up. He can capture waveforms. They can do that, and then put it into your assignment sheet. Okay, I really hit quickly the why you should be teaching scopes to your students. Now let's give you some resources for learning about scopes. Facebook, your views on Facebook can be positive or negative. I belong to several professional Facebook groups. AES Wave has a dedicated section for auto educators, and if you're not familiar with it, this is in your handout. You don't need to write it down. I would join this forum. Automotive Technology Instructors is a Facebook forum that I belong to. Very great place to share information, bounce ideas off, get some help, offer some help. Motor Age has one called Commitment to Training, Pete Meyer. It's a great forum to belong to. There's one called Automotive Educators. Maybe some of you belong to that one. A great forum for discussing and bouncing ideas off each other. Pico has two Facebook forums. One is called Pico Scope Automotive. One is called Pico Automotive Users. I belong to both. You should also if you want to gain valuable information. There's one called Technicians Training Group. There's one called Automotive Lab Scope Diagnostics. These are all in your handout. Again, I'm recommending that you consider joining them. AES Wave Tech Feed, that's not the educator one, that is a technician forum. Auto MD, which is a very nice forum, real professional. You don't get a lot of DIYers saying, what's wrong with my car if it goes left? I mean, these are professional people. Auto Insight Network is another good one. And there's a new one, fairly new out, called Automotive Technician Mentorship Group, where you join, be willing to serve as a mentor for up-and-coming students and entry-level technicians. Very powerful forum. I enjoy it. Many of you may not be aware that CarQuest Technical Institute and WorldPac Training Institute offers free training for instructors. How to access it, you go to that website. Again, that's in your handout. You sign up and you are not charged. It's normal $50 for class or $100 per month. You don't charge anything and you have free access to all of their virtual training. They have like 300 and some classes that they're currently giving. Brandon Steckler is a great presenter. Bryn Klein, Tanner Brandt, all of the great guys that present, Mario Rojas present classes. And many of them are recorded, so you can go back and watch the class if you weren't able to record all of it or whatever. Some of them are recorded. They're expanding this feature as we speak. Of course, International Auto Technicians Network is free to us to join. They have many discussion forums. I know some of you post on the educator forum a lot. They have a very awesome stored waveform library of known good and known bad waveforms. However, even though the initial IATN is free, you must join with a subscription to have access to the waveform libraries. The new one out now is Diagnostic Network. That's a very awesome Scott Brown's group. Everything has been vetted, so you won't see any junk out there or false information. Discussion on many forums. You can ask for help on diagnosing cars or teaching different concepts. They have a very awesome stored waveform library. It's $49 a year for instructors, and that gives you free access to everything. It is not free. YouTube. How many of you have had students come in with their cell phone and say, look, I watch on YouTube and this is what's wrong with my car? YouTube is a very powerful yet also very poor method of learning. So if you search these terms in red, you will get some very valuable, vetted, high quality training videos on oscilloscopes. So use basics, use training, use waveform analysis, use Picoscope Automotive. They have a very powerful YouTube channel. And of course, Scanner Danner has both free and premium YouTube channels. I suggest you join the premium one. It's a very powerful resource for information. Paul Danner is an awesome teacher. He really gets his point across. And Snap-on has a great YouTube channel on their oscilloscopes also. So if you want training on the Veris or Solus or whatever, they have their YouTube channel. Again, this is all in your handout. Pico 6, I want you to become familiar with that if you're not already. Your students should all download Pico 6 software if they're interested in learning how to use the scope. So you Google Pico Automotive 6 software, and this is what you get when you Google it. And it says download Pico 6 automotive software. So you download it. You do not, if you have a Picoscope, do not hook it up to your computer. Leave it unhooked. So let's say a student doesn't have a Picoscope, but he's at home. He downloaded the software, and this is what he gets when he opens up the icon. It says no suitable device found. I didn't see a scope. Do you want to run it in demo mode? And your answer is yes, I want to run it in demo mode. So as soon as it loads up in demo mode, you get a fuel injector pattern that looks like it's live. It drifts across the screen because it wants you to trigger it, but that's not the feature I want you to know about right now. Look up there on the top toolbar, and you see the word automotive. You and your students click on automotive. You get a submenu. The submenu is charging, starting, sensors, actuators, ignition, communication, system test, pressure transducers. These are all submenus that will help you learn some of these additional components. So I'm going to choose sensors. Then I'm going to go to crankshaft. Then I'm going to go to an inductive crankshaft sensor, which is the AC variable reluctance sensor. And then I'm going to choose, I want to learn about it in the running mode. Again, you have all of these submenus that you can access. Your students can do this also without owning a scope. As soon as you access and click on your final choice, it gives you a tutorial of what this passive variable reluctance sensor is, where to hook the scope up, what settings to use on the scope, and how to use it. It's a phenomenal tool. How to perform the tests, settings, where to hook up a scope lead, sample of good and bad waveforms, common DTCs associated with that component, lots of information, free. Now, I know there's some of you that are listening to me that weren't aware of Pico 6 is available without a scope, and you should check that out. It's free. There's a couple of books I might recommend. This one is by Graham Stokes, Automotive Oscilloscopes, available on Amazon and the internet. Pico has one available on the pico.com library/training. Pretty good resource on oscilloscope basics and diagnosis. Useful hardware for teaching oscilloscopes to your students. We have the signal distribution harness. That was what was used in the very first picture that I showed you. This is a totally adaptable. You can hook it up any way you want, inline, T, cross, whatever, to accommodate whatever classroom or shop setting you have. You can hook up to 34 U-scopes to this harness. You can stack 2 U-scopes to 1 student access. You don't need to have 1 scope per black box. You can hook 2 or 3 on the same one. I've had a class where 35 scopes were hooked up to it, and I got a little bit of signal degradation. But normally, 20, 30 U-scopes will be exactly the same signal that you input from the instructors right here. So where you see the trainer with a red and black line connected to here, that signal coming from that trainer is distributed throughout the entire harness. So each student sitting here in the back row with his U-scope plugged in is going to see that same signal that you see up here on your scope. He has to make the adjustments to his scope to get it to display properly. Now you can display yours on the overhead screen. I'll show you how in a minute. And then he can say, okay, I got to catch up and make my time, my voltage, my trigger adjustments to get the same thing. This is a very powerful teaching tool. It's called a signal distribution harness. It comes from ConsuLab. See your rep if you're interested. This is something you may not know about. This is from AES Wave. This is a signal router switch. This allows you on a single channel scope to put in up to 4 signals without changing anything. You hook up your scope leads to 4 different signals, and you control with these switches which one wants to be displayed on the signal input of the scope. Now you can control the ground side or the positive side. That's why there's 2 rotary switches there. This is a real powerful teaching tool. It's not that expensive. Again, this information is in your handout. This is a picture of my setup when I use a U-scope class. I have a IPEVO document camera called a Ziggy. It's about 150 bucks, I think, 180 bucks. And I did some homemade building there to keep everything in line so I can take it apart and repeat it without having to line everything up. Got some duct tape holding things together there. The details of this equipment is included in your handout. This is another setup that I use when I do live testing. You can laugh, it's homemade, it's crude, but it's there's our speed and position trainer. There's a common camera tripod. I made a homemade wooden boom on it with a C-clamp holding my Logitech webcam. And then there's my U-scope document camera, so I can switch on my computer between the U-scope fills the entire screen, whether it's in your whiteboard in your classroom, or your computer, or my computer when I do my training. Of course, the paint can is needed to stabilize the tripod so you don't bump it. It's a full paint can. If you're blessed to have an Elmo in your classroom, you can use that and focus right in on the U-scope. Currently, the U-scope cannot electronically project the display of the U-scope. There isn't enough room inside that small box to have the electronics to have an external display. That's why you need to use a document camera or some other way to display it. If you have a phone, you could put your phone there. If you have your phone's ability to display on a computer screen, you could use your phone to do that. We offer extensive training on the U-scope, including the buttonology class that I just explained to you, how to access and use the U-scope stored waveform library that many of you don't know about, how to use the full function of the vertical menu features, how to save and store waveforms that you copy and paste to the SD card and take them out with a cable into your computer and use them. How all of the forms you saw today came that method. How to use cursors, triggers, meters, screen settings, and so forth. How to obtain waveforms from ConsuLab trainers. Designed to be a hands-on class with you having a U-scope. If you're interested in finding out more about those training classes, contact your rep or me or Rick, and any one of us can help you get connected. I hope that this introductory class on how to teach scopes to your students has been helpful to you. It was not how a scope works. That is another class. Some of you have already had that. This was my opinions, my selfish ideas on how to make this easy to understand for students. Thanks.
Thank you, Mr. Krieger.
That concludes this session. Thanks a lot for watching. Now for a quick word from our sponsors.
At ConsuLab, we design and build training aids for automotive, heavy vehicle, and electrical engineering. Today I want to show you one of our standard products that touches all three domains. It's the EM200-25 Speed and Position Sensors Trainer. The EM200-25 Speed and Position Sensors Trainer is used to demonstrate the operation, diagnosis, and testing of common types of analog and digital speed and position sensors as they operate on a real vehicle. The trainer includes inductive, Hall effect, and magnetoresistive sensors. All sensors are driven by a variable speed electric motor to create different operating conditions. The trainer provides a safe and effective method of demonstrating the operating principles of different types of speed and position sensors used on today's vehicles. Now this product works great for teaching oscilloscopes in a classroom environment. We have individual test points for each of the 4 sensors, and we have motor speed control here. So what we can do is, using the different test points, we can hook up to different sensors, control the speed of the motor, and watch the results on our oscilloscope. Here we can see the electric motor that drives the shaft with the different tone wheels on it. And you can also see the 4 different sensors, 2 of which have gap adjustment. Here we can see a textbook pattern for an inductive speed sensor. Now by changing the speed on the shaft, we can see changes in amplitude as well as frequency. Then by changing the gap adjustment, we can see the effect on amplitude. As you have seen, this product can make it easier to teach oscilloscopes and speed and position sensors. To find out more about our products, visit ConsuLab.com or check us out on Facebook, Twitter, or LinkedIn. Thanks for watching.